Hello everybody, welcome to this live interaction session 1, materials processing, and this specific to casting, forming and welding processes. So this is the first live interaction. Hello everybody course. Welcome to this live interaction session 1, materials processing, and this specific to casting, forming and welding processes. So this is the first live interaction. And it is obvious this we know that NPTEL is actually this online certification course, and of course here we have designed this course for the wide varieties of the audience and in this particular subject. And course module is also designed just looking into the very basic concepts, and of course gradually we develop to understand the very complex process or maybe advanced techniques associated with this particular subject. So in that way, we have presented the subject through numerical problems here also, as well as some theoretical problems through understanding of the lecture videos. So some few cases we have demonstrated some simulation also, just to understand, just to visualize the physical process associated with the material processing technologies. And of course, I hope in this case, basic understanding of the processing technologies is covered up, and both metallic materials and non-metallic materials we have attempted in this particular course, and in that way it might be helpful. Now, if you look into the course structure or course content, introduction to materials processing, then overview of casting, welding and forming processes. Although we are familiar with this casting, welding and the forming processes, but in this case, little deviation from the conventional techniques we have also discussed in this particular course. Then melt process means we understand that casting and fusion welding. So we have tried to explain both for metallic and non-metallic materials for the casting and the fusion welding processes. Then we have discussed about the bulk deformation process. This is basically the metal forming process we have discussed, and that is the called solid process because this is a solid deformation process. So that's why it comes under the solid processes. Even there are solid deformation techniques which is utilized for the materials joining process, that also we have explained. And after that, we categorize this as a powder processing because nowadays it is very important that different technologies relevant to the powder processing we have discussed in details. And then after that, we discuss about the non-conventional processes. So maybe we can see the coating process, different additive process, and mainly discuss in the non-conventional process, which is not covered up in the other conventional material processing technologies. And then finally, focus on the steel processing because it's a very important. The steel processing is very important, and therefore we have discussed single crystal production and fluid flow analysis, steel solidification, and then finally we have discussed the demonstration of the different product processing technologies and case studies. And processing of the electronics and magnetic and optic materials has been discussed finally. So this way we cover up all these subjects, and these are the references. Materials processing. First one, we'll get in details about the material processing, and then if you look into the very physical metallurgy, and that we have discussed next, and then phase transformation in metals also discussed, and finally the welding metallurgy also discussed in the reference 4. If you are interested in fundamentals of physical metallurgy, then also we can in 5, and theory and practice of the steel rolling technology has been discussed in the reference 6. And fundamental solidification you can follow reference 7, and or castings, and as well as both reference 8 or 9 are important. But in reference 9 you will be able to most the different numerical problems associated with the metal casting process, and finally reference 10 corresponds to the metal forming operation. So these are the overall all these references we can discuss. things. And types of questions, maybe both might be 1 or 2 marks, multiple choice type questions will be there. Similarly, what we can follow in the assignments, the same type of question will be in the final examination also. But questions might be both numerical as well as a theoretical type. Both type of questions will be there. And I suggest you try to follow the questions described in the assignment. That will help you to understand the pattern of the questions in the final exam. Now start with the very basic process. I assume that probably very little part has been finished so far. So we started with the casting process. We know the casting process is the simply the very basic steps of the casting process. Is the first we create the through heating we make the molten material, and then we put in the mold cavity, and mold cavity is already designed beforehand, and then within the mold cavity we allow to do the solidification, and then after solidification we perform the finishing processes, and after finishing process we can reach the final product. So these are the schematic of the casting process, basic steps of the casting process. Now, when we pouring the material into the mold cavity, then we follow some design of the gating system. That means how we can pour the molten material or transfer the molten material to the mold cavity. So we have basic element, the pouring basin is there, it can act as a kind of reservoir. And then from the reservoir, it is some strainer also there. Through the strainer, it goes to the further the runner, and there is some important part is the splash core and the skim bob are there. These are basically try to arrest the different kind of the impurities during the casting process. So you see that one strainer is there, and then splash core is there, as well as the skim bob also there. All are the track the different kind of the lighter impurities. They can track the skim bob is basically try to arrest the lighter impurities. Splash core is basically looking into that heavier impurities also can be arrested there. And ceramic strainers can also be used. So these are the very basic design of the casting process, getting design process. So casting process, the first we try to look into that once to understand solidification, it goes through the temperature pattern. So that means the temperature history. So we put the liquid metal, which is in superheated condition. And then when it comes to the solidification time, it's the change the solidification. And then after that, cooling is followed and come back to the ambient temperature. So this is the usual cooling history, or maybe I can say the cooling curve corresponds to the pure metal, typical. Now, one important part of the casting is the riser design and riser placement. So that is also, the riser in the casting acts as a reservoir. So that means it supplies the hottest material when there is a shrinkage volume exists up in the casting process. It means that riser is used for the purpose of supplying the liquid metal because of the shrinkage in the mold cavity. So that's why the riser has to be keep the molten material at the last stage also, so that you'll be able to feed the molten material at the end stage. Now there are two types. Maybe we know the top cylindrical riser, we know that is useful. We can see that what can be the dimension of this or design of the riser. If we assume there's a cylindrical riser we are using because easy to manufacture. And in this case, the volume by surface area, in this case, the minimum surface area can be produced. So that means heat loss is minimized using the minimum surface area for the cylindrical for the cylindrical surface. Now, from the perspective of that, we assume the volume pi by 4 d square h, and then we calculate the surface area responsible for the heat loss, and then minimize the surface area. Once you minimize the surface area, then we can minimize the surface area. We can minimize the heat loss such that material becomes still molten and as compared to the mold cavity. Therefore, if we follow the minimum surface area in this expression, we reach this relation h equal to d by 2. That means the height of the cylindrical riser should be the d by 2. And this is called the top cylindrical riser. Top cylindrical riser is the effective heat transfer area, the side surface, the circumference of the cylinder as well as the top surface. Now, in the side cylindrical riser, in this case, all surfaces are responsible for the heat loss. So therefore, we count all the surface, top and bottom part, and as well as the circumference of the cylinder, we consider. And if we consider this way and minimize the surface area, then we can reach H equal to D. So this way, we can calculate also for the riser design this calculation. So that some idea that what can be the dimension of the cylindrical riser, or we can simply minimize the surface area because surface area is responsible for the heat loss. Even if you got the actual design of the riser, then we can follow the Kent's method also. So that is in that case we can calculate the freezing ratio A by V, that means area by volume for the casting and area by volume for the riser. That ratio indicates the freezing ratio. Similarly, volume ratio can be calculated dR by Vc, volume of the riser and volume of the casting. So X, Y value we can easily calculate, and then we can define the curve that decides that X-axis is the freezing ratio and Y-axis is the volume ratio, and then we can make a boundary that if you maintain this particular position, then we can get the sound casting, another is the defective casting. So here this can be X is the you know that in terms of X and Y we can find out this expression, and then this is the one way to look into the practical point of view what can be the freezing ratio and volumetric ratio such that we'll be able to get the sound casting in this case. So we can design this accordingly. There is another method also, novel research method. In this case also we can calculate A by V for the casting, because A by V for the casting sometimes is difficult. So therefore we can use the shape factor. In this case, shape factor is the length and width and the thickness of the casting that decide the shape factor. And based on the shape factor and the volume ratio, you can make a boundary of sound casting and the defective casting. So the zone of the sound casting, we put any point, pick up any point, accordingly we can use the volume ratio and the shape factor. This is the most easiest way, trivial process. We can find out how to produce the sound casting, what can be the geometric dimension of the riser. Now there is another part is that we can estimate what can be the solidification time. That is very important in the casting process, and it can be mainly the different types of the thermal resistance exist in a mold casting. I can say the sand mold casting process. So if you look into these elements of the resistance to the heat flow, there are three different. First is the air resistance, that means convective heat flow from the mold surface to the air. So that produces some kind of the resistance component, thermal resistance. Then through the mold wall, this is also thermal resistance is also there. And then between the solidified part and the mold wall, that is also, I can say the mold metal interface. Okay, and then at the interface, there must be some resistance. And even when you heat flow through the solid also, that is also some loss might be there. Solid, and of course, at the liquid part also, heat resistance might be there. So therefore, based on that, we can find out there are 5 thermal resistance components are there. Now, if we consider the large casting process, basically sand casting or investment casting, in that cases, we can estimate the solidification time equal to V by A square. So volume by area of the cast. So this is also known as the volume by area is also known as the modulus of casting process. And the solidification factor here, omega, that actually depends on the properties of the mold material as well as the cast material. So one has to be careful that which is the corresponds to the cast material, which is the corresponds to the mold material. So we understand the solidification is proportional to the V by A square. Now, if it is in this case, the thermal resistance of the mold metal interface. So that means in this case, maybe die casting process, the solidification time is different. It depends on the volume by area ratio only, not the square. So that's why here the die casting is something different because we mostly use the mold material, the form of metal. So here, what is the contact resistance is basically between the liquid and the solid, and that solid to mold interface, some resistance exists. So that derivation is already I have explained probably in the main courses, but here we simply overview on this thing that solidification depends on the only V by area ratio. But it has to be careful that HF equal to heat transfer coefficient of the interface. A is the surface area of the interface, and L is the latent heat. So accordingly, we can calculate the what is the in case of die casting, what is the solidification time. Now I come to this point after which we are looking in the melt processes. So after casting, then we next step with the welding process, welding and joining process. Welding and joining process also melting there, but maybe in this case the fusion welding is associated with the melting. And now fusion welding means if we consider the arc welding process, or maybe we can overall if you look into the type of the welding process, we can 3 different types. One is the fusion welding, transition welding, and solid state welding process. Fusion welding means basically we use the in arc welding process, we clear the electrical arc or maybe follow the electrical circuit, clear the arc, and the arc is responsible for melting the material. Either you can use the consumable electrode or non-consumable electrode. So in this way, you can perform the fusion welding process. Thus melting of the material and then solidification also associated with that. So after solidification, then weld joint, permanent weld joint can be observed. So this is one type. Next, transition welding means in this case that it's a molten material is supplied between the two solid interface, but it's a molten material supplied between, and that molten metal is bonding between the two solid component, but without melting the solid component. So that is known as the transition welding. So brazing and soldering is an example of the transition welding. Then we can perform the solid state welding process also, but here there is not involved any melting. So in this case, the frictional heat is generated by some mechanical movement of the any kind of the tool. So such that this motion of this tool is responsible for the heat generation, and the heat generated heat is try to soften the material and plasticize the material. Or at the same time, when you mix the two material, then plasticized material can bonding in the solid state process. So here it is not associated with any kind of the melting, but frictional heat is generated here. So here just example of the friction stir welding. In this case, frictional heating is there. So high rotational speed is applied to the FSW tool, and then it moves from one along the weld center line, but this lateral movement or transverse movement of the tool is very low speed, but this rotational movement of the tool is very high. So that will ensure the frictional heat generation. At the same time, when it is transverse movement is or welding along the welding direction is very low, that will ensure the bonding of the two material through plasticization or mixing of the plasticized material. That is the basic philosophy of the friction stir welding process. So here we usually use the FSW tool is the hardness of the FSW tool is much more as compared to the workpiece material. So such that wear of the tool might not be much high in this particular case. Then we have look into the rolling process, the solid process. I can say this may be related to the solid deformation process. So in this case, thickness of the particular strip is basically reduced through the rotation of the roller, which is contact between these two rollers. When we maintain the gap, accordingly the thickness can vary. So there are different types of the rolling process. So it is rotating the roller, and the workpiece is following from a particular direction. So input and output velocity can be different in these two cases because thickness are reducing. So to maintain the total volume flow rate, so speed should be much more when it is coming out or reduction in the thickness through the roller. So there are different types of the rolling process: ring loading, roll bending, roll forming, roll profile rolling, and control rolling. That means different way we can perform place the roller, different shape of the roller you can place it according to different types of the rolling process are possible. But one important thing is the rolling process, the solid state deformation process, that it is always associated with some kind of the recrystallization process. So mostly, if it is the hot deformation process, we can find out the dynamic recrystallization. If it is cold rolling process, we can find out the static recrystallization. This is in general I am talking about. Forging also we between the two die, we place the material and we press the die to get the shape of the as per the die. So then in that case, material also deform. So in this case also, material can be deformed 3 different conditions: the hot forming, hot forging, warm forging, and the cold forging mode. So in this case, the entire workpiece is actually necessary to plastically deform the process. Otherwise, we will not be able to get the shape of the component. So this is simply applying the load, put the material over the die, and then get the shape of the component through plastic deformation of the material. Similarly, extrusion also other solid deformation process. That is the, in this case, through the workpiece material, we push the, using the ramp, we push the force, compressive force to the workpiece material, and it makes the force out through the die opening in the front with certain velocity. So this type of the solid deformation process is known as the extrusion process. But in this case, extrusion process, since we are applying the compressive load, so therefore little brittle material is suitable in this particular process, because the brittle material is at least deformation happens in the brittle materials with the application of the compressive load than tensile load itself. But both options are there. It may be done at the cold working temperature. It can be done at the hot working temperature, both. Similarly, drying also similar to the extrusion, but in this case, instead of giving the compressive force, we just pull it. That means we apply the tensile force from the front. So that is the difference from the extrusion process. So therefore, in this case, the brittle type of material is not applicable because brittle material is usually weak with the application of the tensile load. So in this case, we'll try to apply the ductile material. So we have different calculation, that degree of drawing operation in terms of the before workpiece diameter, the application and the final diameter of the wear. So mainly any kind of the wear, the different multiple stage we can follow, and we can reduce the diameter of the wear as per the desired size, desired component. So I think that's all. So here I have tried to explain the different kinds of the, I think, very basics of the associated with this casting process, and then different forming processes, and as well as the welding process. I think that's all for today. Now, you have any questions we can discuss on this particular questions. Thank you.
Yeah, sir. During
you have any questions, queries? Maybe you can ask.
Yeah. I want to ask one question. Are you able to hear me? Yeah, sir. During
you have any questions, queries? Maybe you can ask.
Yeah. Can you hear me? I want to ask one question.
Yes.
Are you able to hear me?
Ravindra.
Yes, sir. During
you have any questions, queries? Maybe you can ask.
Yeah. Can you hear me? I want to ask one question.
Yes.
Are you able to hear me?
Ravindra.
Yes, sir. During
you have any questions, queries? Maybe you can ask.
Yeah. Can you hear me? I want to ask one question.
Yes.
Can you hear me? Are you able to hear me?
Ravindra.
Yes, sir. During
you have any questions, queries? Maybe you can ask.
Can you hear me? I want to ask one question.
Yes.
Can you hear me?
You have to sound up. मैं यूट्यूब में जाके मैं राइट साइड क्लिक करता हूँ, वहाँ पे नहीं आ रहा। म्यूट टैब, यस म्यूट टैब, हाँ हाँ म्यूट टैब, यस साउंड बढ़ाया, ठीक है म्यूट टैब, हाँ हेलो hello, okay, hello, is this Ravindra Ramane? Okay, so how to check the temperature during welding process, especially on heat affected joint and oil metal? Okay, this is from theoretical, or you are asking about experimentally how you can measure the temperature? So how to check the temperature during welding process, especially on heat affected joint and oil? Okay. So you can use this is from theoretical, or you are asking about experimentally. Experimentally, okay. How to check the temperature during the process, especially when heat affected joint. Okay. So you can use this is from theoretical, or you are asking about experimentally. Experimentally. How to check the temperature during the process, especially when heat affected joint. Heat affected zone if you do it beforehand, but you can assuming this can be the heat affected zone, and there you can put the thermocouple, and from the thermocouple you can measure the temperature. That is a one option. Or if you have the IR camera, infrared camera also, that also you can use set heat affected zone. If you do it in the hands also, you can assuming this can be the heat affected zone, and there you can put the thermocouple, and from the thermocouple you can measure the temperature. That is the one option. infrared camera. That was we can use say that it will do little gas after that assuming this can eight of the zone. Here you can put the final button. That's what is what is the user of the so that is a one.